are starting our next unit, which is all about quadratics. So we've talked before about how algebra is kind of separated into two general categories. There's the linear of algebra, which is slope-intercept form, y equals mx plus b, right? And then there's the quadratic section. The quadratic section is ax squared plus bx plus c. Our last unit got us introduced to polynomials and factoring and binomials, things like that. We're going to be using all of that stuff, primarily the binomial stuff, in this next unit as we work with another type of equation, another type of graph, a quadratic equation, Paul, Sam, and that makes the graph that looks like a parabola, which is what you see on the right side of your page here. It's a U shape. It can also open downward to make like a frowny face shape, okay? But that is a parabola. And we start with a whole bunch of definitions because you've never done quadratics before. And so there are some terms that we need to discuss ahead of time. And the first one being a parabola. What is a parabola? A parabola is the graph of a quadratic equation. The graph of a quadratic equation. Sam, do you have your binder open?
Not yet.
Taking notes? Come on, let's go. The graph of a quadratic equation. And what is a quadratic equation? A quadratic equation is y equals ax squared plus bx plus c. You should recognize that from factoring. POs 51 and PO 52. Okay? So slope-intercept form, y equals mx plus b, we know the graph is going to be a line. That's our linear function. When you see something with that squared term is what makes it quadratic. That's what makes it a parabola. The graph of a quadratic equation is going to be either a U opening up, smiley face, or a frowny face opening down. Okay? The domain, you've seen that word before. Remind me what a domain is.
It's all the x terms.
Okay, the x values in the relation. The range, you've seen that one before as well, Caitlin.
The y value.
The y values in the relation. How about vertex? Vertex. You've probably heard vertex before in the context of an angle, right? When you have an angle, the vertex is kind of the corner, right? It's where the two sides meet. But with a parabola, it means something a little bit different. Similar, but different. What do you think vertex means, Colin? Yeah, it's where the curve happens, okay? The vertex is the curve of the parabola. And it is the highest or lowest point. And when we say the vertex is the highest point, we say it's the maximum value. And the lowest point is a minimum value. So when you see the words maximum or minimum, as you do if you look down your page a little bit, maximum or minimum, it's talking about that vertex point. It's the highest or the lowest point. So in this case, our example here, okay, which is also down here, okay, but the vertex would be right at the origin there, because that's where the parabola curves. And is that point, is that curve the highest point or the lowest point of the parabola?
Minimum.
It's the lowest point. It's the minimum. Okay? The parabola does not go any lower than 0, because that's where curves to go back up again. All right? So we'll talk more about that in a little bit. And the axis of symmetry, it's essentially the x value of the vertex. And it divides the parabola in half. That's not how you spell parabola. Divides the parabola in half. Okay. This is so exciting.
Not really.
Parabolas, they're fun to say, they're fun to graph. So much fun. Questions on these definitions before we get to analyzing where to look for them on actual parabolas? Nope. All right, then let's go. Your task in this first example of a parabola is to identify the domain and range, each written as an inequality. So remember, we wrote them as inequalities when we covered them back in CO17 or whatever it was. I identify the vertex, the axis of symmetry, and that minimum maximum point, which again is the vertex, right? So, Paul.
So is the domain -2
So looking at the domain here, Paul's asking, is it -2 to +2? Remember the domain is every x value included in the parabola.
Yeah. So
And folks, hey, quiet please. You'll notice the parabola has arrows on each end of it. What do those arrows mean, Paul? Paul, what do the arrows tell us?
that is infinite.
It goes on forever, right? And you can see here, at that bottom curve, as it's going outward to the left and to the right, the gap is getting wider. So if these sides, I shouldn't call them lines, but if these arrows continue on, that gap is going to continue to get wider and wider and wider. It's going to expand to cover every x value on the corner plane, eventually, right? And so the domain of a parabola with arrows on each end is always going to be the same. Paul said it's infinite. How do we show that it's infinite? The all real symbol. Okay? The domain of a parabola with arrows on each end will always be all real numbers because that gap just gets wider and wider and wider. Nathan, question?
Is it? Wait, are we doing range yet? It's pretty much.
Any question on domain? Okay, range. Nathan.
All real numbers.
Why?
Because the line keeps going up.
It keeps going up.
But it doesn't.
Oh, it doesn't ever come back down? No. This vertex point here represents the lowest the parabola goes. It's never going to get below 0 here.
Gravity's gonna take it down.
Gravity does not, parabolas do not follow the rules of gravity. Okay? The range of a parabola is not all real solutions. You need to look at the vertex here and recognize that at 0, right, y is going up in both directions, but it's never going to be below 0. It's never going below the vertex point. So what inequality would be right to show the values that y is going to be?
Y is greater than or equal to 0.
Good. Y is greater than or equal to 0. Okay? Because
Meaning the Y will always be about 0.
on the y-axis here, right, 0 here is the lowest point on the y-axis, and it goes up in both directions, never stopping. So it'll get to 6 and 7 and 8 and 9 and 10 and 11 and 12 on the y-axis, but it's never going below. It's never coming back down. Okay? So the range, y values will always be greater than or equal to 0. What's our vertex point? Briggs, what is so important that you are just involved with everyone around you? I see you talking to Colin, talking to Will, talking to Bean. What is it? Share it. Then stop it. What is the vertex point? Andrea? It is 0, 0, and it is an ordered pair, right? It's a location. The vertex is at 0, 0, right in the middle here. The axis of symmetry, our definition was it is the x value of the vertex. It's an imaginary line, right? So it's not actually drawn in, you can't see it, but it is the line that divides the parabola in half. So if we were to draw an imaginary vertical line going through our parabola, the equation of that line is going to be x equals 0. Because that imaginary line, see, it helps when you pay attention, Nathan, and not talking to Charlotte while I'm going over this. I see that happening. I see it happening. The axis of symmetry is a vertical line passing through the center of the parabola. If you look at the x-axis, where does that line pass through the x-axis? It passes through the x-axis, right, at 0, which also happens to be the x value of the vertex. That's not going to be a coincidence. Okay, our definition for the axis of symmetry was it's the x value of the vertex. The equation is just telling you, reiterating what the x value of the vertex is, and it's the imaginary line that cuts a parabola in half. Parabolas are symmetrical. You'll never have a parabola that looks like this. Okay, like a Nike swoosh. That's not a parabola. It must be symmetrical. Okay, it's called something else. The name isn't coming to me at the moment.
It's not parabola.
Okay, Andrea, you got your hand up?
So if the vertex was 1, 0, then the axis of symmetry would be 1.
X equals 1. Yes, x equals 1. And then the minimum, maximum, again, it's the same as the vertex. And is that a minimum point or a maximum point? It's a minimum point. It's the lowest the parabola goes. Okay? So there you go.
Can you do the next one?
Pretty much it. Certainly. We might even get through the next two if I don't have to tell people to stop talking and carrying on. Okay?
What about words?
So this is an example of a parabola that opens down. Okay? Parabolas can open up or open downward. We'll talk about in CO54 what causes that. But what is the domain? You see arrows on each end here. So this is going to continue to expand downward forever and ever and ever and ever and ever. Caitlin? All reals. That gap is getting wider. And so eventually it's going to continue to expand sideways, meaning every x value is going to be included at some point in both directions. What is the range here? What is the range? Maddie?
Is it x is, or is it y is less than 0? Or greater? Oh wait, hold on,
Take a look at where that vertex
it's
is.
this sign, I just can't remember what.
So where on the y-axis is the highest point of this parabola?
6.
6. So the highest it goes on the y is 6, and then it goes down forever, right? So y is going to be less than or equal to 6. It never gets to 6.1, never gets to 7 up here, never 8, never above 6. Okay? 6 and below. What's our vertex point? Cole.
Vertex point? Is it? Wait, give me a second. Is it 6?
So 6 is the y value of the vertex, right? It's that curve.
It's 0, 6.
0, 6.
My bad.
It's okay. Okay.
I'm big brain.
0, 6. It's that point of the curve. We'll skip down now. Is that point a minimum or a maximum? It's a maximum, right? It's the highest point. Okay. It's the highest point there. And then what is our axis of symmetry? Paul? Again, it's x equals 0. If we put a vertical line through that vertex, dividing that parabola in half, where does it cross the x-axis? It crosses the x-axis at 0. You see, once again, it is the same as the x value of the vertex. Okay? Paul?
Will the domain always be all real numbers?
Yes, when you have arrows on both ends of the parabola. Where that'll change is if you're talking about a parabola in context, right? You know, like we'll get examples of that in CO60. But if you're talking about like a satellite dish, which you think of a satellite dish, that is a parabola. You know, from one end it goes down to the middle where it receives and comes back up again, right? That's not on all reels because the satellite dish doesn't go on forever. You know, there wouldn't be arrows on each end each end there. But if a parabola has arrows on both ends, yes. Cool.
Can we do the first
We're
one?
moving on to the next one once I'm done with questions here. Yep.
I was wondering if we could do this, not the next one, but the second and next.
Nope, we're gonna do the next one.
What do you want to do second?
Okay? Alright, for this one, domain, arrows on each end. What does that tell you about the domain? Well, all real numbers. Take a look at where that vertex is. On the y-axis, describe the y values that are going to be included in this parabola. Describe the y value. Colin.
Y is greater than
Good. Our y values of this parabola are all greater than or equal to -8, right? Because where that vertex point is, on the y-axis, it's at -8, and then it goes up from there. So -7 is a part of it, -6 is a part of it, -5, -4, -3, everything positive, or everything above -8, nothing below it, right? -9, never going to be a part of the parabola. What's the vertex point? This one's a little bit different from the other ones. The x value isn't 0. What's the location of that point? Katie.
3.
Good. 3, -8. The axis of symmetry, that imaginary vertical line going through the vertex, where does this line pass through the x-axis? What is the x value of the vertex? Julian? 3. Our axis of symmetry is x equals 3. That vertical line, where does it pass through the x-axis? Right here, at 3. It also happens to be, not coincidentally, the x value of the vertex. And then that vertex is a minimum or a maximum? Minimum. It's the lowest the parabola goes, and that is the same as the vertex.
Oh, can we do the other one?
Okay. So, what connections do we see here? We already talked about that connection between the x value and our axis of symmetry. What other connection do you see? It's easier to see now that we've done 3 of them, perhaps? Yeah, go ahead, Leah. The vertex and the minimum and the maximum, the same points. What else? What else? Paul, or I was called you Colin. Colin?
Is the domain always
Domain, when you have arrows on each end, it's always all reals. Good. Paul, is that what you're going to say? Okay. Something else, Leah? Yes, the range and your y value will always be the same. Okay, that vertex kind of serves 2 purposes. The x value matches the axis of symmetry. The y value matches the range. The vertex is a very important point of a parabola. You almost might say it's like the central point of a parabola. Get it? No, you can do it.
No,
You can do it.
confusing. It's like 1.5.
Okay? Remember that the x and y axis are like a number line. If I gave you a number line and gave you a 1 and a 2 and said what number is that, you should be able to tell me. I would hope.
1.5.
Okay, right? Think of those axes as number lines, and if you end up with a decimal, that's okay. Just what's the value of it? Okay. All right. The rest of the page is homework for tomorrow. You can do it. That's how you math.
Don't forget to like and subscribe.